really difficult. The first thing you have to look for is division by 0. And you can see you get that when x minus 1 equals 0. So when x equals 1. So this is what's called a point of discontinuity. It's going to affect the intervals, but you have to do that first. You can't wait till the end to do it. It won't make any sense. All right. Next thing here is this 2 really has to come to the other side. So you end up subtracting 2 from both sides, and then it looks like this. It's really 2 over 1. Does that look okay?
Yes.
Like you saw something like this class. All right, now the next thing here is you want to make a common denominator. So the common denominator is x minus 1. You're missing an x minus 1 on the right, like that. So we are going to multiply. So you have 3x plus 1 over x minus 1 minus x minus 1, 2x minus 2. Now this negative really applies to every single thing in the numerator. So once you multiply, or if you wait to multiply, it applies to everything in the numerator. And that's kind of important here. So it's going to end up being minus 2x plus 2, 3x plus 1 over x minus 1, like that. So the reason you can make a common denominator is because, or the reason you can combine the tops because you've got a common denominator. Is that okay so far?
Yes.
All right, still less than or equal to 0. Then you combine stuff in the numerator. So the 3x, the 2x, that becomes x. Plus 1 is plus 3. So you have x plus 3 over x minus 1 is less than or equal to 0. Thing 2 that you do here is you set the numerator equal to 0. X plus 3 equal to 0. And you find that x is negative 3. Yes, you have to do all this. I know it's a lot. That's probably why you asked for help, because like what I do. So you take this point where it's continuous, this point where it equals 0, and you put them on a number line. And mine are never to scale, so don't worry about that. And then you test points. So we're going to test points in each of these regions. And you pick points that are easy to test, like 0 is a good one, 2 is a good one, maybe negative 4. All right, so the next thing here is you're putting these points into the function. That's why it's so important to get this right. If you get this wrong, you're gonna have problems. You could go back to the original, although I don't recommend that, because then you're comparing to a number. It's usually a lot easier to compare to 0 than it is to a number inside 0. So when you put 0 in, and I know the tendency here is to really want to get a number out, you end up getting 0 plus 3 over 0 minus 1, which ends up being negative 3. Because it's negative, I'm going to put a negative symbol there. Is that okay? Maybe you saw that in class.
Yeah.
Then we're going to do the same thing for 2. Do the easier stuff before the harder stuff. 5 over 1, which is 5. That's positive. They do not always alternate, so please don't just jump to conclusions there. But it might be positive, but it's not because it alternates. It's minus 4 plus 3, or minus 4 minus 1. It's minus 1 over minus 5, which is 1/5. That's positive. Any questions, thoughts on that?
No.
All right, so once you do all that, it's less than 0 when it's here. Now, the problem at 1 is that the function is discontinuous. So your interval is from negative 3 to 1. But at 1, it can't be 1 because you can't divide by 0. So that's a parenthesis. It can be negative 3 because negative 3 is exactly 0. Bracket goes there. That is your final answer there.
Okay. What, can you explain again what determines if it's a bracket or parentheses for this equation or problems?
Yeah, so at one it's discontinuous, so it can never be a bracket.
Okay.
Then the negative
Oh,
3
okay. I see
is
it. I
because
see
of this symbol or this symbol. That's why it's okay.
it. Okay. Because the line underneath means it's included. Same with the bracket.
Yeah.
Okay.
If it was a less than or greater than, it would be another parentheses.
Okay.
All right, that takes care of that problem. What is the next one you want us to look at?
Um, 3C. It looks like.
All right, so again, I don't know how to, the pictures were kind of like, they weren't sent as the like original quality. They're kind of, but I can make it,
Mom, do you
that's
know how?
okay. They're good. They're good. They're good enough, but for future, we don't have time to fix tonight.
Okay.
Um, yeah, they just, all right, so we have 6x plus 12, x to the 1/2 plus 10 equals 0. So this is considered a substitution problem for factoring, solved by factoring. So the most common substitution here is to make u equal to the middle, x to the 1/2, or square root of x, which is what that really is. So you're gonna replace x to the 1/2 with u. U is the most common substitution variable, but you have to do a bit more. You have to square u, and that means x to the 1/2 squared, which is really x to the power of 1. The reason is when you have an exponent to an exponent, you multiply. 1/2 times 2 is 1. All right, so now you substitute in for this is u, this is u squared. So it becomes 6u squared plus 12u plus 10 equals 0. Did you see this in class? Like, are these kinds of substitutions something you've been doing?
We don't see a U normally.
What variable do you guys use?
Uh, she does, or I don't know what she does. I was trying to look at my warm up to see a more similar one because I couldn't figure it out either. It's
Okay, but
I'm
did
just
do you,
not familiar with a U.
yeah, u is just another variable. If you used like said, oh, we use y or we use m, or u is just the common substitution variable in math.
Okay.
So to solve this from here, you have a number of options. And I would recommend factoring out a GCF first because it makes it just a tiny bit easier to solve. Although it may not actually have a solution. So, boy, it's really what your teacher wrote. Yeah. Is that a 10? That is a 10, right? It's not an
Yes.
18.
Yes.
Okay. Yeah, because the next thing here is to multiply 3 times 5 to get 15. And you're trying to find two numbers that multiply to 15 but add to 6. There are none. So this ends up being a quadratic formula. Is that by chance possible? Your teacher wanted to use quadratic formula for this?
Yeah, that sounds familiar.
Okay. Well, so let's go back to this line then, and proceed from here because that It's so A is 6, B is 12, and C is 10. And so let's first check B squared minus 4AC. And that is the reason we're checking that is because maybe there are no solutions. Okay. And that is the case here. Uh, that's why I was asked a couple times if that was the right numbers. It's not like not like a -10 or something. So this has no solution because the discriminant part under the root when you're doing your opposite B plus or minus square root B squared minus 4AC. If the part under the root is negative, that means there is no solution.
Okay.
And that's what you have here, which is a bit odd considering they're asking you to solve and then check for extraneous solutions, but this has no solution. So I guess, wait, well, I'm doing the wrong one. That's also a problem. I'm doing E, not C. Oh boy. See, it looked like a C. Okay.
I was doing E2. I didn't even
Okay. C is
realize.
also an issue. This will not take long to correct. C is also an issue because it's plus 60.
Yes. 3x squared plus 60 equals 0.
So if you factor out a 3 from both, it's x squared plus 20 equals 0. This has no solution. There's no number that when you square and add it to 20, you can get back to 0. Okay. What's the next one here to look at? Maybe 4? I don't know.
Yes. Solve the inequality.
Right. This is a lot like the first one we did. It's a good one for us to redo. And just keep in mind, we're about 10 minutes left. So if there's something else you want to work on, maybe prioritize. First thing is to set the bottom equal to 0, because this is a place where it's discontinuous. And you have to look out for those discontinuities, places where it's undefined. The next thing to do is to move the number over to the other side of the equation. So it's -4, and then it's less than or equal to 0. And now you make a common denominator. So you multiply the top and the bottom by whatever the other one is to get a common denominator. So we got 3x plus 8 minus 4x minus 12, like that, over x minus 3. So I did skip a couple of steps here. Because the denominator is the same, you can just write it over the same denominator. You eventually have to distribute this negative in, or you have to treat it as -4 times what's inside here. Kind of up to you how you want to handle that. But it ends up being -4x plus 12, 3x plus 8 over x minus 3. Right? And then you combine like terms, so you end up getting -x plus 20 over x minus 3. So then you set the top equal to 0. -x plus 20 equal to 0. And you end up getting x equal to 20. Is that okay?
Yes.
So then we go back to our number line and we have 3 and 20 on the number line and we have to test points. So you might test 0. That's a good one. 5 seems reasonable. And then 21. and you check them back in this line right here. That's minus x plus 20 over x minus 3. So let me just do a quick check here, make sure I've done this right. Just something doesn't feel right on this. It was kind of bothersome how I did that. Minus 4x plus 12 over x minus 3. Okay. All right, looks okay to me. So now, when you put 0 in for the first one, you get 20 over negative 3, which is negative. It's a negative number. The 5 becomes minus 5 plus 20 over 5 minus 3 becomes 15 over 2. That's positive. And while they may look like they always alternate, just be careful. Could be the exception. So this is negative 1 over 18, which is negative. And you could say, well, hey, Matthew, they've all alternated so far. That's true. Right. So just be careful. So the answer here where it's less than or equal to 0 is minus infinity to 3. And that's the first interval. So with infinities, it's always parentheses. But at 3, what you have to decide is 3 the discontinuity point, or is it okay because it's equal to 0? Since it is the discontinuity point, it's the parentheses. And then you're going from 20 to infinity. Infinity always gets parentheses. But what about 20? Well, 20 is a bracket because it's the inequality part there. Is that okay?
Yes.
All right, so limited time left. What's the most important thing for us to cover here?
Can we just do the one right under that 5?
Sure. I be 4 over x plus 2 over x plus 3 equals negative 3. Is that correct? You said yes, that is correct.
Yes.
Okay. All right, so it says find all solutions of the equation. What you're supposed to do first is actually do the same thing we did in the previous problems. You set the bottoms equal to 0. And these end up being the excluded values. So it's like if you get 0 or negative 3 as your answer, you're supposed to say, oh, that's not correct. I need to check it here. The next thing is that these need to all have the same bottom, which means they're missing something. Some are missing more than another. Do you know what I mean by that? Like, what is the X missing on the bottom that the others have?
Plus 3 and a 1.
Yeah, so we'll say X plus 3, X plus 3. Keep in mind, these are really in parentheses down here on the bottom. The 1 is you can ignore. It's just 1 is 1. It's always there. So the middle one is missing an X on the top and the bottom. And unfortunately, the one on the right is missing the most. It's missing an X plus 3, X plus 3, an X, and an X. Okay. Do you agree that the bottoms are now all the same?
Yes.
So when the bottoms are all the same, you can just look at the top. It's good to kind of just rewrite it with just the top to get rid of all the extra stuff that isn't needed, just could make it a little bit more clear for you. All right, so to solve this, we're going to distribute in 4x plus 12 plus 2x equals minus 3 times. This ends up being x squared plus 3x. So I'm distributing in this way, and it becomes minus 3x squared minus 9x like that. On the left, you can combine like terms. So you've got 12, 6x plus 12. And then on the right, you can bring over the stuff because you generally want that x squared to be positive. So when you add 3x squared, there you add 9x, there you end up getting 3x squared plus 15x plus 12 equals 0. You can factor out a 3 from everything. And this becomes x plus 4, x plus 1 equals 0. You set the x terms equal to 0. So you set x plus 4 equal to 0, x plus 1 equal to 0. And x is either -4 or x is -1. And those do not match up with any of our excluded values, so we're okay. So these are good. There's about many places you could go wrong on this problem. It's a pretty tough one. So I definitely recommend reworking it before your test or quiz.
Okay.
All right. We're out of time for today. Are you on fall break coming up?